Students, welcome to this online course on electromagnetic theory. So we will in detail see about the electromagnetic theory, which is a branch of electrical engineering. So when you step into the electrical engineering, it is very much that you should know about the electromagnetic theory. So first, initially, what is electromagnetic theory? The electromagnetic theory is just a study about the which covers actually the principles of electromagnetism. So if I talk about current, electromagnetism is a basic principle that how the current is formed, generated, or how the current moves from one point to another point, how the force is created, and everything that will be discussed through the electromagnetic theory. So the electromagnetic theory usually has various principles, laws related to the electrostatics, magnetic fields of steady currents, and motional EMF and electromagnetic inductions through various principles like Maxwell's equations, Gauss laws, and various laws that you will come across this subject. So on this entering into the subject, we'll first focus on this unit 1. So the unit 1 is the electrostatics. So the electrostatics, they have separated into two units. The first unit is electrostatics 1, there we'll see about some basics, and the second unit is also about the electrostatics 2, which we will have further in detail about this electrostatics. So initially, to start with the introduction, as I told you, electromagnetic theory is a study of electrostatics or electromagnetism that occurs in between two elements or two particles or something. So electromagnetic theories, we are going to see about a new kind of a force that exerts in some object or some element, and we'll see how the forces comes. And by Newton's law, through the Newton's law, you can understand that F is equal to m into a, where F is a force, m is a mass, and a is an acceleration. So acceleration, it is the rate of change of velocity. So it is the rate of change of velocity, and velocity in terms, it is the rate of change of distance, right? So this is how the acceleration is measured or acceleration is calculated. But the mass of any substance or any object cannot be directly found, because we don't have any specific meters to find the mass of an object. Whereas you can say to find the weight of an object is very easy. If I say 1 kg of any object can be measured through some weighing machines. You have different types of weighing machines to measure. But if I come to mass is something in a universal value, where if you say like it's a constant. For example, if I say weight of an object in this planet Earth, which has a gravity of 9.81, you will have one value. But if you take the same weight of that substance into some other planet, like if you go to the moon and you measure it, the weight differs because of the gravitational force varies. But the mass is something you have which is most very same as that. Everything remains constant in everywhere. It's an universally constant everywhere. And to measure the mass, it is not like so easy. We have some calculation. You don't have any direct measurement devices to calculate it. So for example, if I say in the Earth, whatever the object which is placed or whichever in the space falls to the Earth because of the gravitational force. For example, you have an object here up over the Earth, and it is being pulled down due to a force called as the gravitational force, which can be given as force into mass into acceleration. So this equation can be given for this. But however, if you take the moon, which is far away from our planet, the moon is somewhere very far from this planet, where the force of action towards the center of the Earth, it's also there is a force exerted into it. That's why the moon always remains in the same orbit which comes around the Earth. But that force is given as F is equal to g mass of the moon divided by r square, where r is the radius. And so this force, both the forces differs in this case. So this force, due to for the first piece of an object, the force has actually falls down. This object comes and falls down over the surface of the earth just because of this force which is exerted in this by this equation. But for this is a force where for the moon, the force which does not pull that moon towards the earth, but it has some attraction and it keeps the moon at the same orbit of rotation. Okay, so the force differs. So what we are going to see about here in this subject is about this force acting on each object and also materials, then how these forces are created. And actually force is not created, it has been like how these forces appear into the system. So followed by this, for example, we need to, before going to an example, we'll see a small concept called electrostatics. Electrostatics. So what is this electrostatics? Electrostatics is one kind of a force which is described by the law called as Coulomb's law. The Coulomb's law very well describes the electrostatics force. For example, if I take charges, two charges, let me name the charge as Q1 and this as charge as Q2. And the distance of this charge I'm measuring it as from its center of this particle. I'm taking it as r. The distance is r. That this r, which is the distance, supposed to be r, I can put it as d if you don't have any confusion. D is the distance here. So this distance should be, however, very much greater than the internal radius of this two particles, so that will be r. So it is mandatory to note that the distance d should be very much greater than r, only then it can be applicable. So when these two particles has the charges contained into it, the force created or the force exerted here, F, can be given as q1 q2 divided by 4 pi epsilon naught into 1 divided by r square. So this is the equation. What I'm sorry, it's not r square, this is d square, because we are talking about the distance, so it is d square here. Okay, so this is how the Coulomb's law is given. This is Coulomb's law is explained for the electrostatics. This is how the electrostatics takes. So for now, for an example, I'm going to show you how this electrostatics was. So in your lower classes, or for an experimentation purpose, for understanding, you would have gone through this experiment that if you take a comb, let me consider this as a comb, you're taking it and you're rubbing it over your hair or your head, or or over a thick surface or a woolen surface. Then you bring it close to a piece of paper, and you can see this paper gets attracted and sticks, and you get attracted and comes through the room. You can lift the paper, you can easily lift the paper using this. There is some force between the comb and the paper which is just attracting each other, and it becomes like a magnet. It's like assumed to be a magnet. This happens very easily. But how this happens, have you ever think of it? How does this force that holds the paper, but at the time when you keep or when you give a shake or give a vibrate or give a disturbance to the scope, immediately the paper falls down. It cannot retain its position, or it cannot retain in the force of attraction. Have you ever guessed about it, what has actually happening? So let me tell you what happens here actually. So in this piece of paper is kind of a particle which contains some neutrons, photons and electrons, right? This also contains some neutrons, photons and electrons. For an instant, let me assume that this contains some protons and some electrons into it, it been contained into it. Okay, you have some equal amount of protons and equal number of electrons into it. Okay, so it has this. So at the time when you rub this this comb to any hard surface like woolen or your head or somewhere, what happens is this comb is also actually before coming to that, this comb also has some charges into it, either the few electrical electrons present over here and few positive charges also present in this. So it will be not, it will be scattered everywhere into it, and the equal amount of electrons and positive charges of photons you can find it. So the moment when you rub over any hard surfaces like wool or any, or maybe your head, if you're going to do that, what happens is the electrons from here starts to move away, that the electrons get transferred from this to the the hard surface what you're going. So electrons comes out of here, and once the electrons come out of here, this comb actually becomes more positive. That is, you will not have it becomes more positive, and the count of number of electrons will be less when compared to the number of protons inside it. So you have the majority carriers becoming the protons or the positive charges in the comb. So due to which what happens is, when the piece of paper is brought near, if I'm bringing this piece of paper towards this, I'm bringing it towards this, and I'm just touching the comb, or if I'm using the comb to touch this paper, what happens initially, due to the positive charges inside it, due to the positive charge in the comb which is highly positively charged, or the electrons, the negatively charged particles of this paper are attracted towards the which is going comes closer, it moves and comes closer to the comb. So then it, and the positive charges remains in the other directions, other locations opposite, right? So this is how it happens. So due to which there is a force of attraction, and so this comb attracts the opposite charges, and also this opposite charges which attracts the charges over in the comb. And when the moment when you shake it, what happens is, this piece of paper, the piece of paper which I'll show it like this, the piece of paper which you are using it here, the moment when you shake it, what happens is, these electrons and the holes or the protons in the paper again gets disturbed, and they move or they scatter as they were in the previous, not exactly as previous, but they get scattered, and now the electrons are getting scattered. They are not from the, as in the position that you see in the when they are touch the comb, so we don't have that position here. So what happens, due to which what happens, the force of attraction is been lost, the force of attraction is lost, and therefore the paper falls down. So this is what is happening. So so there is no force. You may think that how the paper comes down, or come the paper falls when we shake the paper, or when we shake the comb, what happens, it's not just because of the gravitational force. The gravitational force is not putting the paper down, but the moment when it is shaked or when it vibrated, the charges get scattered, and charges get disturbed from its position, and that's why that force of attraction is left out, and so it falls. This kind of force is called as the electrostatic force, due to which the force of attraction is being done. So from this theory, we can come to some of the most important note, that is, these charges, the charge q is always conserved, called as conserved. The conserved meaning is like it does not change with respect to time, and the next one is, the charge is always local. The meaning local means what I explained here for the this, that is, the charges will move from one point to another, but they don't disappear. That is the meaning. That is, it is being in the same reference, or they don't disappear. The charges don't disappear. They can move from one point to another point due to some law of attraction or repulsion. They can move, but they will not disappear for a time period and then they reappear. It doesn't happen. That is called as local. And the last one is it is q is always quantized. It is quantized. It's nothing but it is a multiple of the value 1.1 that is plus or minus 1.6 into 10 to the power of minus 19 coulomb. So this is how your charges, this is the main property of a charge in any object. So that's why I told you with this example that how it happens. So I hope you could understand the basic introduction of electrostatics and also electromagnetic theory. Followed by we will see about in detail about your the form, that is equations framing that everywhere we can see that.